Assalamu alaikum, peace be upon you. In this lecture, I will show a simple beam verification example that is present new model and that is present in ETABS. So here I will select the default setting and the example I will select US customary, and the rest of data for the concrete that is same. The concrete design code will be ACI 31814. Okay, so here I will select blank. Okay, next from where I will pick the verification example. Here in the help documentation, a lot of help is present in the form of steel design, shear wall design, concrete frame design, steel frame design. So here I will go in the verification example. Here is the concrete frame design. Here I will pick the first example, ACI 318. So here is a simple example, shear and flexural reinforcement design of a singly reinforced rectangular beam. So here is the beam. Here is the beam total length 10 feet, height of the beam that is 13.5 and 2.5 and 16 inch, and the width of the beam that is 10 inch, and the design property data here. Okay, software will calculate the manual calculations and then verify from the computer model that is we will develop in ETABS. So here is the verification ETABS result and independent manual result. So there is a difference 0%. So we will verify that is it true. So let's start with the input data. Here is the input data. I will close this window. So here the beam length, etc. So first of all I will draw the grid, edit grid data. So there are already 4 story data. We need only the grid in the plan, and 1 bay is okay. Sorry, edit, modify. So here I will select display as spacing. Here I will put 1 second spacing, that will be 10. Sorry, spacing will come at the top, 10. Okay, in the y direction I will just enter 1 grid, that will be A, so that will be okay. Okay, so we need to draw the beam. Here you can see. Okay, so now I will close one window and I will go in the elevation. Okay, and I will pick A elevation, apply. Okay, and you can see the distance, that is 0, and the x distance is 10 feet. Okay, so now I will reduce the number of stories. So we need to draw only 1 beam, so I will keep it 1 story and delete the rest of stories. Right click, delete story data, again right click, okay, 1 story is enough. Heights no matter, we need to verify the beam. Okay, so now that is 1 story data. So I will draw the beam here. So first of all I will define the properties, material property. So here is the material property, the concrete property, that is 4000 psi for kip per inch square and Fy 60. So here I will define new material, and in the material I will select rebar. Okay, that is 60 grade, that is 60 KSI. Okay, and here in the material property that is 60,000 psi, so that is okay. And the modulus of elasticity, that is 2900 into 1000 pound per inch square, that is also okay. 29 sorry, that is concrete. So by default the modulus of elasticity of steel will remain same, that is 29,000. So our steel material is defined. I will put Fy equal to 60 KSI. Okay, so now I will define the concrete material. So here I can pick by default 4000 psi, that is predefined. Fc prime, okay, here that is 4000 psi. So I will hit OK. Okay, material is defined. So now I will define the section, add new property, rectangular beam. Here I will select my material, that is Fc prime 4000 psi, and the beam is 10 by 16 inch. Okay, so depth is 16 inch, width is 10 inch. Okay, and here in the property modifier I will enter the property modifier as per ACI 318 for the beam 0.35. okay, and here in the reinforcement I will select the design as a beam, and the longitudinal bar that will be 60, and for the confinement also 60 grade. Okay, and the from the extreme fiber to the center of the steel distance, that is 2.5 inch to the centroid. Okay, now my beam material is also defined. Now I will draw the beam. Here I have selected the beam, so here I will select my beam type, that is 10 by 16. I will click from one corner to another corner and press hit. Okay, my beam is defined. So I will define the support system. So on the right side that is a roller support, and on the left side that is a hinge. So I will select this end, assign joint strained. So I will assign roller support, apply, and on the left end that is a hinge, I will assign apply. Okay, my support system is also defined. So next, section properties is also defined. Okay, so now we have to verify that is it our modulus of elasticity of concrete materials is 3600. I will go material define, check in the Fc prime modify. So here you can see that is 3600 and there is a variation. So I will put 0 and again 30, 1 2 3, that will be 1000. And in the you can say the shear modulus, that is automatically corrected. Poisson's ratio, that is 0.2. I will hit OK. The software will automatically update the properties everywhere. So that is also defined. So here in the question, a simply supported beam is subjected to an ultimate uniform load of 9.736 cubic feet. This is the example is tested using ACI. This code, the flexural and shear reinforcement computed is compared with the independent hand calculated results. Okay, so here you can see the calculations. Okay, 1.2 dead plus 1.6 live, so it is the ultimate load. Okay, the 9.7 in this self weight of the beam, live load, all loads are included. So the total load, that is the 9.736 cube per feet. Okay, 9.736. So I will apply this load, select this beam. Okay, so assign. In the frame loads, distributed load, and here in the uniform load I will apply live load. Okay, so I will consider as it is, that is a factor load, 9.736 kip per feet. So here is also kip per feet. Control V, apply. You can see the load is applied. So we no need to apply extra factors because this is already factored load. So that's why I am not applying extra loads. That is already factored load, the ultimate load. So next thing, I will save the model. Beam design verification. Save. Okay, my model is saved. Now I will go in the define load combinations. I no need the load combinations. Why? Because I have applied my factor load in the live load. So I will check my results against the live load. Okay, so I will again in the load pattern, I will put it 0 and modify. Okay, and define load combinations, add new load combination. There is no dead load, so that's why I have put dead 1, and the live, that is live 1, or you can delete dead, that will not matter. Okay, so 1 in the combo 1, so I will check the results against this combination. Okay, now I will first of all run the analysis and check my bending moment and shear. Is it comparable with the hand calculations? Let's see in the force/stress diagram. Okay, here I will select shear 2 and here I will select live, apply. So what are the values? You can see on the one end, that is, I can right click, the maximum shear value is 48.680. so let's see what are the values. You can say the shear value, that is a 37.73. that is a design shear, not the sport shear value, that is a design shear value. So that is 37.73. in the design of shear design of the beam, we calculate the value of shear at a distance d. Okay, so our distance d is 13.5 inch. Okay, so we will come back 10 feet minus 13.5 inch. Okay, it's going the illegal value, so I will use the calculator. Okay, so 10 into 12 minus that will be 13.5 inch. Okay, so that distance is 106.5 inch. 106.5 inch. Software will automatically convert into feet distance. Okay, here I will hit okay. So here at a distance d, the value of shear is 37.727. So here you can see in the verification 37.73. Software in the manual, that is rounded off 37.73. so here that is 37.727. so rounded off 37.73. So now let's see the design moment. The design moment is 1460.4. so here our the design moment, maximum moment, show maximum. So our the maximum moment is, that is in kip feet. So let me change the units, consistent units, kip inch. Okay, the moment is in kip inch. Okay, apply. Now let's see again, right click. Here my maximum moment is 1401, so here is 1460. So why it's happening here? This ETABS software is a finite element method software, so it calculates the values of shear or the movements or any values at the defined location, or you can say at the finite location. So software had divided this beam into 1, 2, 3, 4, 5 parts and calculated the results. Okay, so that's why software did not calculate the result at the mid. You can see the bending moment at the center, that should be you can say a curved portion, but that is a straight portion. Okay, so how we can change? Okay, I will close the model. I will divide this beam into 10 parts so that it can show the more refined results. I will edit the frame, divide the frame. Okay, I will divide the frame into 10 parts. Apply. Okay, so now you can see these small beams have been defined, but this total beam length is 10 feet. You can see at the bottom x is 0, and at the horizontal the total distance is 120 inch, so that will be 10 feet. The total distance is 10 feet, but I have divided this beam into multiple parts. So let's see again, run analysis. Now I will go in the display. Okay, shear 2 or moment 3, you can say apply, right click, and here you can see the answer is at the center. I am seeing the result only at this location, center. So my maximum moment is 1460.4. that is the exact moment, that is 1460.4 kip inch. So our moment is also verified. So now let's see the you can say design results. For the design, concrete frame design, here I will select design combinations. I will select this combo. You can see in this combo one live is present. Okay, so now I will run the concrete frame design. Design is completed. I have divided the beam into small parts, so that's why I will go in the center. So let's see what is the maximum. Sorry, I have closed the PDF. Let me again open the PDF and verifications, concrete frame design, open. Here you can see the tension reinforcement AS in inch square, that is 2.37. so here you can see at the center the area of steel required, that is 2.37, and in the manual calculation that is also 2.37. Flexure design. Okay, here area of steel required, you can check also by your manual calculation the area of steel, that is 2.37. so in the software that is also 2.37. so now let's see the shear design. Okay, you can right click, and here in the shear steel no shear reinforcement required. Okay, you can again click shear. Okay, so here rebar area of shear steel divided by spacing 0, no shear steel required. When no shear steel is required, we have to provide the minimum shear steel as per ACI code formulas. Oh, sorry, I have again closed documentation. Sorry for my mistake. Okay, here. So in the shear design, here is the data, all the data, and here at the end you can check our shear capacity, that is much more than the applied shear. So that's why no shear reinforcement required. So we have to provide the minimum steel. So minimum steel, either when we provide in the software or in the manual calculation, the shear steel will be 0.041 inch square per inch, and in inch square per feet that will be 0.492. So 0.041, so that is also verified. Thanks for your time, and that's all for today. Have a nice day.